I can't really hear the guy in the back, so if they're talking about something we all need to know, they might need to get closer to the computer.
Alrighty.
She was technically the tutor. Yeah. She's allowed to go in, but the thing is, she has classes during the times that we leave.
Yeah. Okay. Yeah. I think it's fine then. Yeah. That's probably fine. Okay. Sweet.
Promise I won't ask you to do it if
No, of course
it was
not.
against the rules.
We're supposed to give away the secret.
Oh my
What
god.
secret?
Of having help on the quiz.
Oh, well, we're supposed to have the TA at one point.
Yeah, that's what you said. Okay.
Okay.
Every so often there is someone who tries to help. I can't do that.
Alrighty. So.
So, did anyone have any questions on the homework?
Everything? Got an option?
I think the homework's pretty simple to craft.
Well, Abby, did you download the like quantitative inference sheet?
Yeah, I have the quantitative inference sheet.
Okay. So what specific questions do you have?
So I guess like what is the difference? Start on question. So it says, explain the difference between conducting a hypothesis test with one mean and sigma unknown and conducting a hypothesis test with matched pairs. So what's a sigma? First of all, you know what it is?
Yeah. Did you guys know this stuff first?
What's a sigma?
What's sigma stand for?
That's the with
Variant.
Okay, hold on.
So that's the alpha. Wait.
So
Is sigma this one? Wait, how we draw it?
yeah.
Like that, like the fish.
No, that's alpha.
Okay.
Sigma, I think they're talking about the one with like the O and the little line.
Oh, with the squiggly.
Yeah.
That? Okay.
So what does that variable stand for?
Is it in like a circle or something?
Yeah, it's like
Yeah.
Yeah.
So we're talking about one hypothesis test with one mean without knowing standard deviation. Conducting a hypothesis test.
I think if you turn your desk around, I might be able to hear them all better.
Okay. Let's go like this. And then like this. Haha.
I can hear better now.
I go like
So
this.
look in the mirror.
No, you can turn your computer back around when we do the quiz and stuff. It just like when the computer's further away, it's harder for me to hear.
That makes sense. Okay. So our question was difference between a hypothesis test with one mean versus a hypothesis test with matched pairs.
So is the matched pairs like obviously this is a matched pair because they tell us it's a matched pair. But like is it because we're comparing and contrasting between the two? think?
Yes.
Yeah.
Okay.
So it'd be like if you had data for like, I don't know, apples without pesticides and then apples like with pesticides or something like that. I don't know. Just
Like comparing data
yeah, of the same thing.
of the same thing.
Sort of. So let me draw some. So that's fine. So there is a difference between comparing things, comparing paired things. So I could have a sample. I could do maybe men and women or something, and I could say take a sample of men and figure out their shoe size. So maybe Bob's shoe size is 12, Joe's shoe size is 10, on and on. And I could take a sample of women, maybe Sally's shoe size is 6, Jane's shoe size is 9. Keep going like that. So these are 2 samples, right? 2 separate samples. How do you know whether they're paired or independent?
Would it be independent because they're both like different in a way?
Same person.
Yeah.
Not from the same person. Yeah, that's usually how you can tell. So it doesn't, if Bob has size 12, it doesn't depend on what she has. Yeah. Sorry. So you have an independent one, the 2 samples, when any person or any number you get from the sample isn't connected to another person in the other sample. So if I said maybe this is when they're 12 and this is when they're 20, and this is Bob when he was, well, these are backwards probably, but this is Bob when he's 12 and this is Bob when he's 20, these would be a paired sample because now they're from the same person, kind of like you said. You could also kind of have a paired sample test if you're talking like Bob and his wife, Sally. But then they still are kind of paired. Does that make sense?
So a matched pair is comparing samples from different people?
From similar people.
From
like
similar
the same person usually.
People.
Usually it's someone before and after. That's usually a paired sample.
Similar people. Okay. So
yeah, why is number 2 a paired sample?
it says explain why this is an example of paired data.
Yeah, why?
Why? You're asking me why?
Yeah, why?
It would be paired because they're from the same person, right? So this
Sure.
person he tried flint and steel and battery and steel wool.
Right.
And then this person did the same thing and so on and so forth.
Perfect. Does that make sense to everybody?
Yeah?
Can you repeat that again? Sorry.
Okay, so on number 2, why it's a paired data is because Adam, so same person, tested flint and steel as well as battery and steel wool, as well as Dallin, Juan, Logan, Payne, and Terrence.
Okay.
Does that make sense?
I believe so, yeah.
Okay. That makes sense, Claire? Okay. So
What else are we talking about?
and then according to the, what's it called again? 68, 95, 99.7 rule. 95% would be 2 standard deviations.
Perfect.
So what they want. So what's the difference between a confidence interval and standard deviation?
Good question. Draw on the board again.
Sorry guys, I have a lot of questions today.
All right, it's good.
Okay, so they're closely related. So standard deviation, what's the standard deviation? Somebody tell me what that is.
It's the little markings.
It's little markings, yeah. We got like -1, -2, -3.
Mm-hmm.
What does it mean?
Is it like how much away it is from the center?
Yeah, it's how spread out the data is. So if you have a standard deviation of 12, you're going to look something like this. If you have a standard deviation of 0.1, you're going to look kind of like that. It's how spread out everything is. So, and this is usually the height is like the probability. So the middle is going to have the most probability. Way out here, you have a really tiny probability.
Okay.
So yeah, go ahead.
Then the confidence interval is we want to know the probability of 95%.
Kind of. It's the probability. We want to know to a certain confidence or certain probability. You kind of think of it as where the real mean is. So I'm going to take a sample of 20 people and I'm going to get a mean of like 20. But the real population mean could be all the way over at 30. I don't know. I took a sample of people. People sometimes are super tall or super short or something. So the confidence interval says to within 95% confidence or 99% confidence, we're sure that the real mean of the entire population is within this bound. So if our confidence interval was like, our confidence interval was at a mean of like 12, our confidence interval was from 9 to 15. And we would say we're 95% confident the mean height or the mean shoe size is within 9 to 15. Does that make sense?
Yes.
Mm-hmm.
So it's related to your standard deviation because 9 is going to be some number of standard deviations away from your mean, and so is 15. But it's not the same thing.
Okay.
I feel like that didn't quite go over so well. What's going on?
I got it.
You got it?
Yep.
Got it? Okay. All right.
Yeah.
What's going on?
Okay. Well, we can do the quiz now.
You probably too.
Oh man.
The first one is check all that apply. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? A simple random sample is drawn for each population. X bar is normally distributed for each group. Mean is greater than 0, or the sample size must be the same for each group.
I'm getting the loading.
So
I think one of them that's checked is definitely that X bar is normally distributed.
I believe so.
I was supposed to mark all that apply. So is that the only one?
Requirements must be checked when conducting a hypothesis test.
The only one that I'm not sure about is that U must be greater than 0.
Yeah, I don't think it's that one.
But I think all the other ones apply.
Yeah, I believe so too. I was thinking like the first one for sure.
Yeah.
I was guessing.
So simple random sample X is normally distributed. The sample size must be the same. Yes. So when you're testing stuff, it's got to be the same. Otherwise, you get skewed data.
Mm-hmm.
Okay, so we got the first two and the last one, right?
Yes.
Yep.
So then the next one is the test statistic for a hypothesis test comparing two means with independent samples is a That would be the t-score, right?
Yeah.
Yeah. So
Oh, good. We talked about this one.
then it says two samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2. It's the latter one. Yeah.
Yeah, knowing which subjects. Tells you nothing. Right? That's why we're going with the second one.
Mm-hmm.
Okay. And now we get to do the stuff with Excel.
Woohoo!
Easier than actually having to.
Do it by hand. All right, and we're using the dentist one. So that can go away.
Come on, dentist. Open up.
And we also need the quantitative one as well, right?
Yeah, the quantitative inference procedures under two sample t-tests.
I believe so, yeah.
So here's the data. Represents a simple sample. I'm just going to read it out loud. So it says, for the next 6 questions, use the data file, dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let the mute the one. I don't know how you say that.
The null hypothesis.
Yep, the null hypothesis be the mean bill at the Idaho.
Different part, sorry.
Oh,
I think that's just the mean. Let mean one be the mean bill.
yeah, and the other one be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis. HA mute 1 equals mute 2, and the alternative hypothesis, the HA mute 1 is less than mute 2. Use the level of significance alpha equals 0.10, so 10%. Right.
Okay, so for these questions, we literally just look at the data, right? And change it over, like copy it over, and paste. You know what I mean?
So what type of test would this be?
Less than, right?
I believe so.
The paired sample test, right? On a quantitative inference procedures thing.
Is it paired or two sample?
Honestly, it's the two sample.
That's what
Hey Becca, which Excel are you using? Are you using the paired or the two sample?
So on the video, it said 2 sample t-test.
Okay.
So why is it a two-sample t-test?
Because they're not coming from similar people.
Kind of.
They're both dentist office.
Right.
This out. Yeah.
But they're like independent from each
Ah, they're independent from each other. That's a good way to put it.
other. Okay.
Another reason too is the paired sample test, you only care about the differences. How well someone does, how well the one dentist does on one day versus how well the other does on the other day. They're not really related at all. So the difference between those two wouldn't really tell you that much.
Okay.
So that's why we average them separately and then we find the differences for independent. But I like how you said it better, just they're not really.
And the level of significance is 1.
The degree of freedom we got 37.9.
Plus the DF, right? Okay.
You guys got 37.996 for the DF, right?
Yep.
It's not showing up on mine.
Why are you always the best?
I don't
It's not even your fault.
know.
Scroll down a little.
Okay, 37.996. Okay. Sorry, guys.
And the
Sample standard deviation.
Rexburg, which
Right,
was
so Rexburg. So Rexburg is the variable two.
So I got 206637, right?
yep.
Awesome.
Wait. For what?
The standard deviation for the Rexburg, which is a variable 2 under
I
the.
got 206.637. Is that what
Yeah.
you said? Okay. I heard something else.
Okay.
I took a whole class about word in itself.
Alrighty. So now it says, what is the test statistic down to the 3 decimal places?
Is that just T?
0.434?
But does the negative matter?
Negative does matter, yeah.
So would it be negative 0.434?
So I was watching the video and it's plus or minus 0.434.
Right, so that depends on whether you're doing one-tailed or two-tailed type. So let's talk about this test statistic in real fast.
Okay.
So like on the old one with the Z-score,
Mm-hmm.
you plug that in tablet, right? And then you have it'd be like, I don't know, right here or something for -0.4.
Mhm.
So let's tell you on average, well, it's not on average, it's telling you your mean for the sample is 0.4 standard deviations from the hypothesized mean or something. So the direction does matter because if you have a negative one, that means it's smaller. If you have a positive one, that means it's bigger. Does that make sense?
Okay.
So because this is a less than, it would be negative?
Not necessarily because of the less than, just because the direction matters because it'll tell you whether it's bigger or smaller.
Okay.
So if you did like a less than on this, it would give you a different answer than if you did a greater than because. So I guess maybe one way of putting it would kind of be like, if you did a less than for 0.4, it'd be the same as doing a greater than for -0.4. That makes sense. If that doesn't make sense, then don't think about it that way. Okay, don't think about that. Just remember that the sign does matter.
Okay. It'll be, yeah, 0.333.
Got 0.66654.
You need to change the type of test. And
So what would the
less than. And confidence level is
So is that what the alpha means?
Yeah.
The confidence level.
No, those aren't the same thing. They're really related. But it's your alpha. So what do they give us in the problem? It gives the alpha or the confidence level.
They
That
give
one's
the
in
alpha.
here.
It says level of significance alpha.
Right. So your level of significance is similar to confidence interval, but confidence interval is 1 minus alpha.
So
The
So-
p-value just tells us whether to reject or fail to reject.
Does that make sense?
So the level of significance would be 0.10, but then confidence interval would be. So when we put in confidence level would be 90% instead of 0.1.
Yeah, or we do 0.9 at the end.
Mhm.
Oh, I have 0.95. Does that matter?
I'll just change your confidence interval. So if you don't need to enter in your confidence interval, it won't change anything.
Okay.
So for the p-value then, I got 0.33.
Mhm.
Okay.
So what is the correct decision? Fail to reject?
Okay.
Because the p-value is greater than alpha.
So suppose that you use alternative hypothesis, μ1 does not equal μ2. What's the correct decision based on this evidence? Well, it would be different, obviously, because if they don't equal each other, that means sufficient evidence that they're different, right?
So are we on question 11 now?
Yeah.
That's what I'm talking about.
Okay, so if you go into your Excel and change it to not equal to, then you get a different p-value, but it's still over the 0.10. So I would say that we have insufficient evidence that the mean dentist bills between the two cities are different.
Yeah, that's what I was saying. So we have
Okay.
sufficient evidence that the mean dentist bills between the two cities are different.
Because they're
Because
saying
we are. Okay.
So do we have insufficient evidence that the bills are different, or sufficient evidence that they are
Are they the same or are they different?
So when we're talking about the same or different, what are we talking about is the same? Are we talking about the p-values are the same, or are we talking about
Well, because the p-value is different,
right?
but everything else is the same.
So what is the question asking?
It's that, like, the null hypothesis, μ1 does not equal μ2.
What's the question asking? Is it asking what it's asking?
What is the correct decision based on this evidence?
Oh, so it's asking whether we should fail to reject or reject, right?
Well, we already chose
We already rejected.
fail to reject. And
So why do we-
changing it,
Failed to reject, sorry.
changing it just made the p-value bigger.
Right.
So we failed to reject because the p-value is greater than alpha. So what it's asking is,
So go up a little bit. So we did their test again. We went to Excel and plugged in not equal. was our p-value for not?
0.666.
So we
Something,
had
something.
0.66 here, accept or reject.
Well, you're still gonna reject because it's greater than the alpha.
So you're thinking about it backwards. When we have bigger than the alpha, that's when we fail to reject.
Yeah.
That's what we did when we had 0.33, we failed to reject.
So we're accepting the alternative.
No, so not accepting. So you only accept the alternative if your p-value is less than alpha.
So
So if I get
Failing
it,
to reject the null, the same as accepting. the alternative?
no, those are different things.
failing to reject the null is like saying we accept the null. But a roundabout way.
There's two things
We
you can
fail
do,
to
right? You can
reject.
either
It's
take
a
the
double negative.
alternative or you take the
So we're taking the null.
you're gonna take the null, yeah, because you don't have enough evidence to say that we should take.
So
So in the first one, before we switched it to equal to, we said not enough evidence, right?
Mm-hmm.
So what do we do? We accept the null,
we accept the null.
right? So you don't have enough evidence to overturn it.
So we have insufficient evidence that the mean dentist bills between the two cities are different.
Perfect.
Okay.
Okay. Question 12 we can answer without doing the data yet. Does it suspect that a freshman from Utah cooked dinner for themselves a different number of times than freshmen from Colorado? And so the null hypothesis is that they're the same, but we want an alternative hypothesis for them to be different.
So it would be the second one, right?
Yeah.
Because we want them to be not equal to each other, right?
Right.
Okay. So this is A, B, so that would be a 95%
Perfect. Good job.
confidence interval. 95%. So then we can sense now that it's objective. Probably makes my sister happy too, because I don't have to call her every day. And then
Test statistic is what
Okay, I have a question.
Mm-hmm.
How do you clear out the variable 1 column?
you just highlight it and press delete.
I do that, but it never works. I don't know why.
You could always do the command Z until it's nothing again.
And then the type of test.
Yeah, it just goes back to the top. It's super weird.
So you can click over the number. So I'm gonna share my screen again.
Okay.
Alrighty. So if we're over this number right here, right?
Uh-huh.
And then just go like, just delete it. And if you go over it, and then go like that all the way to the bottom where you'd like it to, it just erases everything.
Ah.
Does that help?
Yeah.
Sweet.
Thank you.
No problem.
Okay, so I have a question. Is our type of test greater than, not equal to, or less than? So we're testing the not the null. The other one? Is that what we're doing?
Yeah, I think it-
Alrighty, so for 13, where did we get the test statistic?
It's T.
Which is it?
0.845.
845, right? Okay. And then for the p-value, did you guys get the 0.4? Wait,
We have 0.411.
okay.
1.01. So
What decisions do we make? Do we reject or fail to reject?
well, the alpha is 0.5, 0.05, and the p-value, that's what we're testing it against, right,
Mm-hmm.
is 0.41, which is greater than the alpha. So we would
Fail to
fail
reject.
to reject the null.
Perfect. You guys got it.
Now it says determine a 95% confidence interval for U1 minus U2. An estimate for the difference between U1 and U2. Input your answers below. So now we go back to the paired t-test, right?
Do you know here?
I think so.
So we would want to stick in one or the other. So either we should do our test in a paired, or we should do our confidence interval. Right? Does it make sense to go between the two tests for the same data?
So I can
Thing.
this.
And I suppose we might get the same. No, we could do you guys.
Into a pair.
When they're paired, they're probably a different p.
Oh.
So we're going to figure out first off, is this a paired sample test or is this an independent sample test?
Well, it's talking about cooking. Well, the first one is about dentists. And they're independent from each other, so they're not paired. And then the other one is talking about cooking students, comparing students from Utah to Colorado.
Is that paired or
I mean, the students are independent from each other
okay, so we probably want to do an independent samples test. Then, right?
on both of them.
Okay. So, so basically, we were debating if we should have, if it was a two sample test or if it was a paired. So if it was independent or paired, and we decided it was independent because of the two different groups.
Because they're
Okay. So then how do we do this? We keep it on the two sample t-test, but then how do we find the margin of error?
You guys think?
So first we need to change the confidence level to 0.95, right?
Right. Perfect.
It's 0.90, right? Or is it?
Whatever it is. We can put that.
Mine's already at 0.95.
Okay.
Yeah. 0.95 for both of them.
There's only one confidence level.
Mhm.
Yeah.
Okay.
And
So-
so would we look at the confidence interval on the equal variances not assumed
Yeah.
column and then do the whole like 1 minus the other divided by 2?
It's your margin of error.
Yeah.
I'll do it.
All right, so what do we do? Like the 5.147 minus the negative 2.214, or would it be the negative 2.14 minus?
So we could do either one. One would give us a negative answer, and one would give us a positive answer. So if
Alright.
we're talking about an error, we usually just make it positive.
Okay, so
So the first one,
So actually what I did when I took this class is I made like a little equation for it in this Excel document, so then I did never have to calculate it. So you guys might want to do that. But you don't have to.
Oh.
So how would you do that if you wanted to?
so we would do the
Equal
I.
on a random thing.
Yeah, let's do some kind of sum that equals it.
That would be equal.
I-23.
Type in equals and how those are the formula.
equals.
You click on the cell you want it to do. So hit the bigger number first, right?
Mm-hmm.
So click on the bigger number.
Where?
Down to the confidence interval.
Oh,
You just click on that, it'll see whatever in that box, I'll use my calculation. And then we're subtracting the small number.
Mm-hmm.
yeah.
So minus, and then click on that one.
And then divide by 2.
Right, we have to divide the whole thing by 2.
So what I have to do,
Yeah.
parentheses around it then? No. that's not-
Yeah, this is another thing. It's hard sometimes. You have to click on the box right there.
Okay.
So I got 3.68.
1. Right?
Yeah.
Okay, that's what I got too.
And enter.
There you go.
0.3, no, 3.68.
I maybe label that because then you can always go back and any other time you run any other data, it'll always calculate the margin of error for you.
That's smart. See, there's a reason why I needed to do it.
I'm glad I did something to it, right?
Okay, and then when it asks to input the lower bound, is that just the negative 2.214?
Yes.
No, fine. Don't worry about it. We do it every week, twice a week, so we're fine. Just know that our teacher from Washington, might see you. It's fine. They're a pretty face to look at.
And then the upper bound is 5.147.
Okay. Here it goes.
Before you submit, actually, let's take a look at one of these questions. So let's look at the Excel document we have.
Okay.
We're doing an independent samples test, right?
Mm-hmm.
Notice variable 1 has more data than variable 2 does.
Mm-hmm.
So currently, there's a question about independent samples tests, whether they had to have the same number of data. Let's look at that one again, because I don't think this is kind of showing us that they don't have to, right? Otherwise, it's getting mad at us saying what are you doing.
That's true.
So let's go look back at that one. I wasn't sure myself, but when that came up, I was like, it was somewhere early on, yeah.
Yeah, that was 3. So
So we could probably throw off whatever one that was saying.
that was the last one. The sample size must be the same for each group.
Yeah, so we
So it's just the first two then?
Mm-hmm.
Okay. So is that everything? Or-
And then what about
That was
that?
the only thing I noticed. There's not, I'm not gonna tell you if that's,
Independent.
And then, so what's the fancy U thing called again?
what's the one?
The what? The mu?
Yeah, mu. What about it?
So it's just like the mu is.
And which question?
So it was talking about how, like, with that mu is.
Greater than 0?
So what? That's a type of hypothesis test. What type of hypothesis test is that?
That was a greater.
Yeah, it's just a greater than hypothesis. We don't have to do
Okay.
greater than because if we did not equal, we did less than.
Okay.
So it's not a requirement.
Okay.
But it is part of it. It's just not
Right.
required that it's greater than. Okay.
We got 13, 17, and 18.
We got which ones wrong?
13, 17, and 18.
How?
So how did we get the
So
margin of
17
error
or 18
right,
are the two ones.
but the lower and upper bounds wrong?
Because that's my question. Is like question 13. I literally just put it from the data into this, and it says it's wrong.
So 0.845 isn't correct.
And you got the ones after 0.845 or whatever it is, right?
Yeah, we got 14 right. 15.
Okay, let's look at 17 and 18. Those are the ones we just did, and see if we can figure out what those.
The lower bound and the upper bound.
That is strange. That means we probably used the wrong.
Get the margin of error, and the margin of error is right.
Yeah, that is very strange.
That keeps happening to me on like all of my quizzes.
Yeah, me too.
Okay, so margin of error is right. Let's go up to where does it talk about the data set we're using?
It's
So it says in the information for the next question, use the data file, freshman's diner, the Excel sheet. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let the mu1 represent mean number of times a month that a student from Colorado cooks dinner, and let mu2 represent this mean for Utah students.
so do we need to do
So let's look at our data set. Maybe it's from data set. So where's like the table that had the raw data? So it said
Oh,
was
Colorado was mu1 and we put in
was it flipped?
mu2.
Okay, so that did it.
Gotcha.
Wait,
So we had it flipped around. We had the Colorado in mu2 when it's supposed to be mu1.
oh.
that's not fair.
Why does that make it?
So
Because
would the lower bound be negative 5.147?
that's my guess. I don't know off the top of my head if that's quite how it changes, but it's gonna be some kind of flipping like that. I think you're right. I think it's just the lower bound is -5.
That's so annoying.
I think I remember this one too. Now that you're doing it, I remember this one being flipped. You were like, "What?"
Maybe you should tell me about something like that.
I think it's probably on purpose. They probably just want you to not display a bunch of numbers. So.
Probably.
Because they hate us.
Well, I mean, if you really took this data yourself, you might accidentally put in different words than you had in the test.
Okay, so then how in the heck did we get 13 wrong?
Second, I'm still doing the thing.
Yeah, well, just switch sides. That's nice.
Okay.
Sweet.
So 13. 13. It does. It changes because it's negative now.
Right.
You have to put a negative in.
So remember I was talking about how the negative does matter? This is telling us now that one of them is, if we had a positive there, we'd be saying that let's see, we did mu1 minus mu2, is that right?
Mm-hmm.
Yeah.
So odds of this test statistic would be telling us that the people in the category 1 have on average a higher value, whatever, what we're talking about cooking time. So people in category 1 would have a higher cooking time than the positive test statistic. The negative one is saying people in category 1 have less cooking time. So that's why the sign matters. You're concluding in totally different things if it's positive versus negative.
And for what question was that for? Was it for A? 13?
Yeah.
Because once you switch it around, you get a negative.
So how do you know if it's switched around? Just because it's not equal to? That means that it has to be negative?
The data in backwards. It told you mu1 was Colorado, is that right?
Mm-hmm.
And you actually put in the Utah ones for
mu1. Yeah.
So as long as you put it in the right, as long as you match your mu1 to your column 1, you'll be fine. You won't have to worry about switching.
Oh, okay. That's good to know.
All right.
Good job, guys.
Boom goes the dynamite. We got 100%.
Jay,
Jay?
Yeah.
Thank you so much.
you're welcome, guys. I have
Appreciate
that
it.
up. Yes.
Yeah, we got it. Thank you so much.
Thanks. Okay, I'm gonna post the recording.
I'll
Okay.
teach you.
Bye, guys.